Today on GarageGuruTV, we finish up our 5.42 valve engine build with our short block from JBA Speed Shop, along with components from TrickFlow Specialties, Stage 8 Locking Fasteners, and Tuff Stuff Performance Accessories. Hey, this is DJ Martin and welcome back to GarageGuruTV. We're really excited today because we got back our 5.4 2-valve short block from JBA Speed Shop. Our friends over there balanced and blueprinted it and got it all ready for the TrickFlow top end going on it today. Today we will be assembling the entire top end of the motor and getting it ready to go back into our chassis. We have components from TrickFlow Specialties. It'll all be buttoned up with Stage 8 Locking Fasteners, and we have some awesome components from Tuff Stuff Performance Accessories as well. Let's take a deeper dive into the components going onto this motor.
The foundation of our engine build is a Windsor 5.4 liter iron block out of a 2000 Ford Expedition. The whole short block was balanced, blueprinted, and assembled by JBA Speed Shop here in San Diego, California. It uses the stock Ford forged crankshaft with ARP main studs. The connecting rods are new stock style connecting rods with ARP bolts, and the pistons are cast replacement units with a 20 thousandths overbore for a final bore of 3.572 inches, which is the minimum bore required for our aftermarket heads. The compression ratio will be around 9.5 to 1. TrickFlow Specialties is the go-to company for performance parts for the 2-valve Ford V8s and for almost every other domestic V8 for that matter. Working our way up the engine, TrickFlow Specialties provided us with their top-of-the-line cylinder head for the 4.6 or 5.4 2-valve mod motors, the Twisted Wedge Race 195 cylinder heads. These heads are not simply ported Ford-style castings. TrickFlow identified areas of improvement of the Ford cylinder heads and changed the fundamental geometries of valves and other parts of the heads. With that being said though, TrickFlow's 2-valve heads will bolt right onto any 4.6 or 5.4 2-valve engine. The 195 race heads we have here are further CNC ported. They feature 195cc CNC'd intake runners, 95cc CNC ported exhaust runners, and 44cc CNC machined combustion chambers that are drastically improved over the Ford heads. TrickFlow's cylinder heads for the 2-valve mod motors are also carb legal. We will be running TrickFlow's Stage 2 TrackMax camshafts for the 4.6 or 5.4 2-valve engines. They have a duration of 234 degrees on both the intake and exhaust lobes at 50 thousandths of lift. The valve lift with the factory rocker ratio is 580 thousandths on both the intake and exhaust, and the lobe separation angle is 114 degrees. The RPM range for these camshafts is 1800 to 6500 RPM. Topping our engine is TrickFlow's Track Heat EFI intake manifold for the 4.6 2-valve engines in the powder-coated black finish. This cast aluminum intake manifold features shorter 11-inch intake runners with a large cross-section favoring higher RPM and larger cubic inch motors. These TrickFlow intake manifolds are cast from A319 aluminum, meaning they are safe to use with nitrous. The RPM range is 3500 to 8000 RPM and is port matched to our 195 race cylinder heads. We topped our intake with the upper plenum that uses a bullet-style oval throttle body. Topping our heads are TrickFlow cast aluminum valve covers in black powder coat finish. These valve covers won't flex and crack like the factory plastic covers. They also look great with their ribbed and machined finish. They feature a baffled PCV connection and threaded fresh air connections for boosted applications. Tuff Stuff Specialties helped us top the look of our 5.4 with their silver bullet 225 amp alternator in black. They also supplied us with a 1.9 horsepower gear reduction starter motor to get us going. Tuff Stuff products are all new, not remanufactured components. Fastening our engine together is Stage 8 Locking Fasteners. These fasteners are made of aircraft quality 4130 chromoly alloy steel with a duplex nickel finish and feature a unique positive locking mechanism that I will demonstrate later in this video.
To build the top end of our 5.4 2-valve mod motor, or to build any engine for that matter, you're going to need a wide variety of quarter, 3/8, and half-inch sockets, and metric and standard, as well as some deep sockets, some wrenches, and a bunch of basic hand tools and ratchets, all the things that you would expect to need for an engine build. On top of that, you're going to need a bunch of different assembly lubes and sealants. First off, we have this engine assembly lube that we'll use for things like cam lobes. Then we have this product from Permatex called the Right Stuff. It's a great gasket maker. We're using several ARP fasteners on this build, and this is ARP's proprietary lubricant for their threads. For any bolts that go into a water passage, you'll want to use a PTFE thread sealant like this Loctite version. On our cam bearings, it's recommended that we use this Cleveite bearing assembly lubricant. And lastly, you'll just want some engine oil because you'll want to put it on several different components as well. Let's get building.
There is no left and right casting for these heads. However, you must assign a head to the driver and passenger side at the beginning of the install to install them. We have the heads labeled with paint marker. In the US, left means driver and right means passenger. First, verify that this 1/8 inch NPT oil restrictor pipe plug is installed on both heads. It is located in the triangular pocket on the deck of the heads. Install the 2 other 1/8 inch NPT pipe plugs into the oil passages on the decks of each head. Use extra PTFE thread sealant on all pipe plugs and ensure these plugs are recessed from the surface as to not interfere with head sealing. There are 6 1/8 inch NPT holes to plug on the exhaust sides of both cylinder heads. Install 1/8 inch NPT pipe plugs on all 6 of these holes on both heads. Next, we will install an 1/8 inch NPT pipe plug at the rear of the driver left head on the chain tensioner mounting pad. Install an 1/8 inch NPT pipe plug at the rear of the passenger right head on the chain tensioner mounting pad. The chain tensioner oil feed holes facing the front of the vehicle do not get plugged. On the front of the driver left head, install a 1/4 NPT pipe plug into this hole on the machined face of the head. You'll want to fill this hole flush with RTV sealant so the timing cover seals. Then install a 1/2 inch NPT pipe plug on the front of the driver left head. On the back of the driver left head, install a 1/4 inch NPT pipe plug here. On the front of the passenger right head, install a 1/4 inch NPT pipe plug here. Fill this hole flush with RTV as well. At the rear of the passenger right head, install a 1/4 inch NPT pipe plug on the machined face. Lastly, install a 1/2 inch NPT pipe plug at the rear of the passenger right head. When installing new heads, it is best practice to install new lash adjusters. These are new lash adjusters from TrickFlow. Soak these in engine oil and then bleed them down slowly in a bench vise. Make sure not to mar the adjuster ball. Coat them in clean engine oil and slide them into their bores. They should feel silky smooth. And then repeat this for all 16 lash adjusters. Remove the cylinder head camshaft caps one head at a time. Only remove the 2 inner M8 hex bolts. Do not mix and match these caps as they are precision matched to their lower halves. Lubricate the camshaft bearing journals and camshaft surfaces with the included lubricant. Install the camshaft marked L into the driver left head with the threaded cam bolt hole at the front of the head. Reinstall the cam caps in the exact orientation they were removed. Coat the cam cap bolts in oil and thread them into the heads. Torque them in the recommended sequence to 150 inch-pounds or 12.5 foot-pounds. The camshaft should now rotate freely and not have excessive end play. Repeat this exact process for the other cylinder head.
Our TrickFlow heads are fully dressed with their camshafts, all the pipe plugs, and the lash adjusters, and we're ready to actually put them on the engine. When you're using the Race 195 TrickFlow 2-valve twisted wedge heads, you're going to also need to use TrickFlow's 3700 bore head gaskets. They're made by Cometic. They're a multi-layered steel, great design. You need to use the 3700 bore, not the stock ones, because the valves are much larger on the 195 heads. So we're going to go ahead and put the head gaskets on, and we're going to use some TrickFlow torque-to-yield bolts. So we're going to douse the threads of those in some engine oil, and we'll put the head gaskets on, we'll put the head on, and then we'll torque down the bolts. You'll need a 15mm socket and then a torque wrench set to 30 foot-pounds. You're going to torque these down in 3 stages. You're going to start at 30 foot-pounds, going in the sequence that the manufacturer recommends. The second stage is an additional 90 degrees, and the third stage is one more stage of 90 degrees, and then your heads are installed.
Before installing your heads, wipe out all of the bores to remove any dust or debris. It is also good practice to chase the head bolt threads, and any other threads on the block for that matter. Slide the head gaskets over the dowel pins. Make sure you install them facing the correct direction and on the correct side of the engine. A second set of hands is useful when installing the heads onto the engine. With the heads firmly seated on the engine, begin threading in the head bolts coated in engine oil. To keep track of which bolts have completed each part of the torque sequence, use a paint marker to mark them. A torque angle gauge should be used to accurately complete the final torquing steps.
With our heads cinched on, we're ready to start working on the timing set. The first thing we need to do is install the crank sprocket. There's 2 styles of crank sprockets for these 2-valve motors. There's one with an extra little extrusion at the back, and there's one that's identical on both sides. You'll want to go ahead and make sure you're using the same one on your engine build as what you took off. So I coated the inside of it with a little assembly lube, and we're going to slide it on the keyway on the crankshaft. Slides all the way back. Now we need to set the engine at top dead center, so I'm going to thread in our old harmonic balancer bolt all the way. And top dead center on these engines means that the keyway on the crankshaft is at the 1030 position, and the dimple on the crank sprocket is at 6 o'clock straight down. When installing aftermarket 2-valve cams onto your Ford mod motor, you're going to have to use the bolt-on style cam sprockets. The factory used some press fit ones for a while, but those don't work here. In addition to that, you will also need cam spacers. If you already started with a bolt-on style cam gear, you'll probably have these. But if you don't have them, Modular Motorsports Racing out of Camarillo, California makes these beautiful billet aluminum ones that are hard anodized. With the front journal of the camshaft all lubed up, we're going to slide the cam spacer on. And then align the keyway. You know the cam sprocket is the right way on because you'll see the dimple for the timing mark on the timing chain. Line up the keyway. And then we just have to torque on our cam gear bolt.
The camshafts have a hex in the center so they can be held in place while you torque them. Torque the cam gear bolts to 100 foot-pounds. Repeat this process for the other cam gear.
Now that we have our cam sprockets all buttoned up, let's go ahead and put on our timing chains. We already have one put on, just we wanted to figure out where everything went. And we're going to go ahead and do the passenger side. So we have the timing mark that's on the cam sprocket kind of in a 11 o'clock position, and we have the crank sprocket in the same spot with the dimple going straight down 6 o'clock. On the timing chain, you're going to see 2 black links. Those 2 black links will straddle the dot on the cam sprocket. Then we're going to guide it over. And there's 1 black dot that will line up on the white dimple. We painted it white with a paint pen on the crank sprocket. So let's just work this around. There we go, we're lined up on the crank and the cam sprocket.
Next we will install the pivoting chain guides. The pivoting guide with the hump that sits above the pivot bore is for the driver side chain. Slide the guide over the pivot pin above the oil pump with the wear strip on the chain side. The pivoting chain guide without the hump is for the passenger side chain. Slide this guide over the pivot pin on the left side of the oil pump with the wear strip on the chain side. Now we will install the timing chain tensioners. Fill these with oil prior to installation and make sure they are in the retracted position with the clip installed. Slide the tensioner pin into the recess on the chain guide while aligning the bolt holes. Torque the 2 bolts to 20 foot-pounds. Repeat this process on the other side. The fixed chain guides are next. Identify which guide goes on which bank by the bolt hole spacing. Slide the strip behind the chain with the ribbed side facing away from the chain and thread in the 2 bolts. Torque these bolts to 96 inch-pounds or 8 foot-pounds, and repeat this process on the other side.
That was a lot of steps. Let's go through a checklist to make sure we have everything done with the timing set. So the first thing we did was we installed the crank sprocket and timed it to top dead center with the dot pointing straight down. Then we slid on our MMR billet cam spacers and then torqued down our bolt-on cam sprockets. After that, we went ahead and slid on our chain tensioner arms on both sides. Then we bolted on our iron chain tensioners and torqued those down. And then we bolted on our chain guides. With all that together and everything torqued to spec, we could then slide on our reluctor wheel onto the crankshafts, lining up the keyway. And then we could put on our front timing cover. One last note before you put on your timing cover is to pull the pins on your chain tensioners. Before we install our timing cover, we have to put RTV at a few joints. We have to put RTV at the joints between the engine block and the oil pan at these 2 points. The 4 points that connect our new cylinder heads to our block, so 1, 2, 3, and 4. And then if you didn't get it before, we have to fill up these 1/4 inch MPT pipe plugs that we put in the front of the head with RTV flush. With RTV applied at those joints and our front timing cover seal installed, we could slip on the timing cover.
Start one bolt near the center so the timing cover is held in place, and then install and torque the rest of the timing cover bolts in sequence. One thing to note if you are using the TrickFlow heads on a Windsor block is that you must use 6mm timing cover bolts, where the heads are, as opposed to the factory 8mm bolts. It's a new day in our shop and we're going to finish up the valve train. We opted to use 4 GT Supercar rocker arms. These are stronger and stiffer than the regular 2-valve units and are better suited to high RPM, high performance applications. You can pick these up at modularmotorsportsracing.com. Make sure to soak the rocker arms in oil for a while prior to installation. To install the rocker arms, you will need this specific valve spring compressor for 2-valve engines. Some part stores may have them, but we picked ours up on Amazon. A second set of hands is almost mandatory when installing rocker arms, as one person must apply the leverage to compress the spring, and the other person needs to fish their sausage fingers under the cam and make sure the rocker is seated correctly. Next to go on are the TrickFlow cast aluminum valve covers. Make sure to install the included O-ring seals and apply a little RTV at the joints between the heads and the timing cover. Thread in and torque the M6 bolts to 100 inch-pounds. Repeat this on both valve covers.
One company we're extremely excited to be partnering with on this build is Stage 8 Locking Fasteners out of San Rafael, California. Stage 8 Locking Fasteners engineers, designs, and manufactures locking fastener systems for the automotive, aviation, marine, and industrial applications. Stage 8 Locking Fasteners started their career in the automotive field with locking header bolts, of which we will be using on this engine. We're also going to be using locking bolts on pretty much every other bolt on this engine, as well as many components of the suspension. Let me show you what's so cool about Stage 8 Locking Fasteners.
Stage 8 locking fasteners feature a patented unique positive locking mechanism that holds the bolts or nuts in their orientation without spinning. With 0 reported failures of their products, Stage 8 locking fasteners can and should be used everywhere they can on your vehicle to keep you going down the road with peace of mind. Stage 8 offers countless specific bolt kits for headers, intake manifolds, collectors, oil pans, valve covers, turbos, CV joints, the list goes on and on. But if you have a really unique application, you can always contact them and they will be able to set you up with a perfect set of locking fasteners. One perk I've found with using these fasteners is that I feel more at ease using anti-seize on fasteners like header bolts, knowing they won't back out. But when I need to remove those header bolts, they come out easy. With your bolt fastened and torqued, slide the retainer over the fastener such that it restricts movement in the loosening direction. Next, slide the E-clip over the top of the bolt into the specially machined fastener head and listen for the click.
We just installed our harmonic balancer back onto the end of the crankshaft and went ahead and torqued down our new ARP balancer bolt. I had to have my assistant put some bolts in the back of the crankshaft and hold it with a pry bar so that when I torqued the new ARP bolt, the engine didn't spin. So let's go ahead and install the rest of our front accessory drive.
Front accessory drive components and their locations vary drastically among the 2-valve engine family, so use this engine only as a guideline for your accessory drive. Our AC delete pulley was previously installed. First, I installed the driver's side idler. Next, the water pump pulley. The belt tensioner goes on now. There is another idler pulley that goes on the passenger side, but at this time they were back ordered.
Then go ahead and torque all these bolts down. Let's install some spark plugs. This is one of the Achilles heels of the mod motor, certain mod motors at least. What happened was the Ford factory didn't install any, or in some cases just not enough anti-seize on the threads of the spark plugs. But we have brand new TrickFlow heads, so we won't have that issue. So we're gonna apply liberally anti-seize onto the threads of our spark plugs. These are just Motorcraft spark plugs, kind of stock replacements. So we have our spark plug socket. We're just going to pop it in there, slide it into the bore, and we're going to torque these to 13 foot-pounds. And just repeat it on the other 7 cylinders. Next, we're going to install a set of shorty pace setter headers that are made to fit the 5.42 valve motor. This is where the Stage 8 locking fasteners really shine. This is where they got their start. If you've ever installed headers in a car, let alone on an engine stand, you will know that header bolts can be some of the most difficult bolts to get to. They're impossible to torque. So if you ever have a header leak, you do not want to go back down there and tighten those again. That's why Stage 8 locking fasteners are a must on header bolts to reduce headaches. So I'm going to go ahead and put on these headers with the Stage 8 locking fasteners.
Stage 8's header bolts feature a hex head with a recessed 3/16 Allen head, which makes it easier to access some of the bolts. Make sure to use anti-seize on these bolts as they will experience extreme heat cycling.
With all the header bolts tightened down as much as we can for some because they're really hard to reach, we're going to go ahead and put on the retainers and the E-clips onto our Stage 8 locking fasteners. Well, that's all the engine building we can do here in the workshop. The next time you see this engine and us, we'll be in the studio sitting this engine between the frame rails of our all-wheel drive Model A. Right now we have to go inside and finish up engineering the intake adapters to put the TrickFlow track heat intake manifold for the 4.62 valves onto our 5.42 valve. So let's go take a look at that intake adapter.
I designed a set of intake adapters in Autodesk Fusion 360 off of pictures and reference dimensions from the TrickFlow heads and intake manifold. The ports match the intake and head ports beautifully. At first I planned on 3D printing these out of a nylon filament. However, when considering the cyclic heating of these components, I decided I wanted to make them out of aluminum. How would I make these out of aluminum? That's where our newest piece of machinery, the Carbide 3D Shapeoko Pro XXL, comes in. The Shapeoko Pro XXL is a large format desktop CNC router made by Carbide 3D. It has a working volume of 33 by 33 by 4 inches. With its extremely rigid construction, the Shapeoko Pro will make easy work out of the 6061 aluminum billets for the intake adapters. This machine will allow us to really up the game of our builds and allow us to explore new techniques and technologies that we can share here on GarageGuruTV. We would like to thank TrickFlow Specialties, JBA Speed Shop, Stage 8 Locking Fasteners, Tuff Stuff Performance Accessories, Modular Motorsports Racing, and Carbide 3D for the support on this engine build. If you would like to see more videos like this, make sure to let us know in the comments and hit that subscribe button. From all of us here at GarageGuruTV, thanks for tuning in and we'll see you next time.